So quick revision. I'll ask question and you'll raise your hand. Okay. So what is a moment of force? Who will answer? Moment of force. Correct. Force into perpendicular distance. Correct answer. What about you? Moment of force. I know by action of the force and what distance? Pivoted. Okay, good. Moment of a couple. Raise your hands. If you dare, don't raise, I will choose. So, moment of a couple.
When one foot acts on the body and another foot acts from another position, couple is formed, but not on the same time.
Couple is formed, but I'm saying moment. What is moment of couple? Okay, here's the question carefully. What is moment of couple? Those who have answered that. What is moment of couple?
Equal forces acting equal and parallel.
I'm not asking what is couple. What is the question? What is moment of a couple?
I also know what is a couple. Right.
You also answered what is a couple. When two forces acting at different points, two equal and opposite forces acting. So you're answering what is couple. I'm asking what is moment of a couple.
So it's the force in the entire distance between both the points.
Yes. So it is one of the forces of couple. One of the forces of the couple multiplied by perpendicular distance between them. Okay, that is moment of a couple. An easy answer is it is the turning produced by the couple. Understanding is turning effect of a couple is called moment of couple. Okay. What is moment of force? Turning effect of a force is a moment of force. Still here, okay. Now, what is equilibrium? What is equilibrium of a body? When do we say the body is in equilibrium? Who will answer? Who will answer? Complete, not full. Give her a second chance. Yes. When do we say? Let's say this book. Is it in equilibrium?
Yes.
So how?
Then it is in a state of rest.
So its state of motion does not change.
Yeah.
Under the influence of several forces, when the state of motion of the body does not change. You didn't come for the last lecture, right? इसलिए So बहुत कुछ ऊपर से जाएगा फिर last lecture में जो cover किया हाँ क्या अच्छा ठीक okay everybody got it when several forces are acting on a body still its state of motion is not changing. If it is in rest, it remains in rest. If it is moving, it keeps moving. Now it can move either in a straight line, then it continues to move in straight line. If it was rotating, then it continues to rotate. While several forces are acting on it, then it is said to be in equilibrium. Okay? Chalo. Example of equilibrium. How many types of equilibrium? Okay. Chalo. Dynamic का एक example दो. Dynamic equilibrium. Wait. बैठ जाओ. Huh? Dropping of a drop, water drop, rain drop. Okay, good. One more example of dynamic equilibrium. Huh? Very good. Any other? This is equilibrium. Who says no? fan rotating at a constant speed. Equilibrium.
What is our cup of water kept on our dashboard of
Correct. That is which equilibrium. Which-
it's static.
Water is not moving. It is still in the glass. Okay. One more
Washing machine.
is dynamic or static?
Dynamic.
Dynamic. Static. और एक static का example दो. ठीक है. So everybody has concepts cleared on equilibrium of body.
Dynamic.
Next, we are going to start today is principle of moments. Principle of So principle of moments is applicable to the body in equilibrium. Okay. This is applicable to the body in equilibrium. So if the body is in a state of equilibrium, then some of or clockwise movement some of the ball anti-clockwise. Okay. So if a body is in equilibrium, then sum of all the, let's say this is the beam balance, right? So two weights are hanged, one on the left side, one on the right side. So when will it be in equilibrium? When it remains horizontal. So it is possible only when the two weights are equal. So if the two weights are force, that means this force is causing whatever moment it is causing, it is balanced by this side, and that's why it remains horizontal. Clear? So if the body is in a state of equilibrium, then sum of all the clockwise moments acting on the body is always equal to sum of all the anti-clockwise moments acting on it. Okay? Now let's verify this. Yes. Anybody has any question on this? So let's verify. Verification of principle of moments. Okay. So how can we verify it? We can verify it with the help of a physical beam balance. So consider we have a physical beam balance rod like this, and it is pivoted at the center, supported at the center on some vertical fixed rod. Okay. Now we have an arrangement, let's say a ring, in which we can hang some weight on either side. Okay, let's say this is your calling W1. Likewise, we can have a so this is experimental verification, right? So we have a bigger weight now here. Okay. And from this center, let's call this distance as L1. Distance as L2. When will we say that the rod is in equilibrium? When it maintains horizontal position. Okay. So you will see this is the rod is always horizontal. It is observed that the A is horizontal. Horizontal represents that is in equilibrium. Only if W1 into L1 is equal to W2 into L2. So you can keep W1, W2 at various positions because you can slide it. Okay, and then you can find out that change the weights. Sometimes you make this heavy, this lighter, alter the weights. Then you make the rod horizontal. So then you can note down L1 and L2 and W1 and W2. You already know. So you'll find that this is horizontal for all this, for this condition. So this verifies, right? What is W1, L1? W1, L1 is anti-clockwise movement. W2, L2 is clockwise movement. You can hang more weights. Say W3, W4. Then you will find that plus W3, let's call L3. This is equal to W2, L2 plus W4, L4. Right? So what is L4? This is L4. This is L4. So sum of all the clockwise movement is always equal to sum of anti-clockwise movements, and that is your principle of that. How do you verify? Rod should be horizontal. Okay. So what is the position of?
What's the full form of that?
W is weight. Weight. And L is the perpendicular distance from the pivot. L is length. Moment arm. Yes. You were present for the last class. So L is nothing but the distance from the pivot, okay, and the force acting. The force here is weight. Is everybody clear on what is weight and what is mass?
Yes.
Okay. So weight is force. Okay. Yeah. Any other question? Anybody? So with this, we are done with unit A. Okay. Unit A of chapter 1. Now we will go to unit 2, which is about center of gravity. Then we'll take up numericals. Unit 2 is center of gravity, CG. So anybody has any question before we go to unit 2? Sorry, unit B. Center of gravity. What it is called? Also. So CG is a very important concept. In terms of center of gravity is very important concept. Anybody knows what is center of gravity? I'm sure you have heard about it. Can anybody explain what is center of gravity? You have to demonstrate also. Yeah. Okay. Sit and answer.
Midpoint of any object is basically center of gravity, which balances the body.
Which balances the body. Very good.
For example, like if we use, for example, if we place it in a finger and it balances the point.
But then is it the midpoint? Is it a midpoint?
No, it is the center.
It is the center of gravity. But not necessarily a midpoint all the time. Midpoint for symmetric bodies. Symmetric bodies. Okay. Now, what is a symmetric body? Like a sphere, or a ring, or a meter scale. These are all symmetric or uniform bodies. What is the meaning of symmetric body? Let's say if this is a symmetric body, right? Then its mass distribution in every cross section will be same. Right? So if you take the center, right of center.
Sir, I can't see you.
Okay, can you now?
Yes, sir.
Okay. So symmetric body is something, right? Let's say this is the center of the symmetric body. Then to the right and left of the body, the mass distribution will be same. This is the meaning of symmetric body. So, for example, I am giving you some shapes. Let's say this is a rod. Okay. Then you have a sphere. So this is a rod, sphere. Okay, is it a symmetric body? What about cylinder?
Yes.
Cylinder is a symmetric body, right? What about cone?
Yes.
Is it symmetric?
Yes.
Is it symmetric in the sense of rod and sphere?
No.
It's not symmetric like rod and sphere.
Yes.
Then you have ring. Is it symmetric? Huh? So we'll discuss that. Okay. It is symmetric not in the sense of sphere, rod and cylinder. So how do we define center of gravity? Let's first define it. So what is center of gravity? He said the body can be balanced at the center of gravity, right? So it is a point. Yes, it is a point where the entire weight of the body is assumed to be concentrated. बोलो. I think you can reach out and कैसे करते हैं? Do that. Okay, now it is a point where the entire weight of the body is assumed to be concentrated. Now, among these bodies, how to find the CG of the body? How to find the CG of the body?
Center of
For symmetric bodies, generally it is the symmetric center. Symmetric center. Okay. So it will be center. What about cylinder? Midpoint of the axis of cylinder. What is the axis of cylinder? This is the axis of cylinder. Midpoint of axis of cylinder. What about cone? So how to find the CG? So try to suspend this body. Let's say you tie a thread and suspend it. Okay. So CG is always below the point of suspension. Okay. So in this case, how to find? So if you hang it like this, then how it will be? It will always be like this. Okay. It will be horizontal only when it is like this. Exactly at the center. So you have to hang it at two positions. Wherever they intersect, that will be center of gravity. Okay. So if it is exactly in the middle, then it will be horizontal. But you hang it like this, then it will become like this. You can try it at home. So what did I say? Center of gravity is always below the point of suspension. Note. CG of a body is below the point of suspension. Okay, this is how you can find. Okay. So for a rod कैसा होना चाहिए? Uniform cross section. Throughout uniform. Then it is the center. So for rod it is geometric center. Sphere also geometric center. So I'm just writing center. It is geometric center. Here also center of axis of cylinder. ठीक है? Ring. What about ring? Center. Now for ring, is the center lying on the object? Okay, so it is not necessary that the center of gravity will always lie on the object, like in case of ring. Then how do you know that the center of gravity is there? Huh? Are you familiar with plumb line? Are you familiar with plumb line? Yes, sir. So plumb line is nothing but any thread to which a weight can be attached. This weight is generally in the form of a cone. So you might have seen those laborers working on, raising the ball. So they have a plumb line arrangement. So that plumb line always points towards center of arc. So they do the labeling, proper labeling of the ball, okay, with the help of that. So if you had tied the ring over here, let's say you mark various positions A, B, C, D. Okay. So this ring was hanged like this. Right? So this was point A. We mark the other diametrically opposite end. Then you hang it with at this point D. Then this plumb line will give you another diametrically opposite end. So you'll find somewhere it is cutting. Okay? So you hang it at multiple points. So the intersection of that point will be the center of gravity. Okay? So this holds in every case. Right? Now let's come to cone. So this cone could, so here sphere could be hollow or solid. Okay. So for both solid or hollow sphere. Right. Let's say this is a hollow cone. So for hollow cone, this is the height of the cone. Let's say this is the height of the cone. Then CG, if you make this height into 3 equal parts. Okay. So for a hollow cone, it is at this height, h by 3. So it is closer to the base. Why? Because the mass distribution is more near the base. So the stability of the body is governed by its mass distribution and geometrical shape. Okay. So it is symmetric to the left and right of the height of the cone. Okay, it is symmetric in that sense. But the same is not true horizontally. I mean, right now it is kept, so it is vertically symmetric on both horizontal sides. But if you hang it like this, then it is not symmetric. Is it clear? Now, so this is the case for hollow. What if it is made solid? Then it becomes, so you make 4 equal parts. So for solid it is h by 4. It becomes more heavier towards the base. So which is more stable, the hollow cone or a solid cone? To which cone it will be easy to topple, the hollow or the solid? Solid. No, hollow.
Can you explain?
Yes, I will explain. Okay. With, let's say, okay, imagine this is the base which has more area, right? We are just trying to demonstrate, right, the stability of this object. So this area is bigger. The base area of the duster is bigger. What about this area? It is smaller, right? So let's check the stability. or we will check the stability in case of this duster and the marker. Okay. So if I try to topple like this, is it toppling? Huh? It's not toppling because its center of gravity is lying in the base area. Too many people coughing. Huh? Why don't you go out, gargle and come back? Okay. So if the base area is more, then it is stable, right? Now let us say we have this pen. What is the base of this pen as compared to duster? More or less? Yes. So let's say I try to balance it. It's balanced, right? Now I topple gently, just like I did for duster. Is it standing? No. So it is unstable. Why? Where is its CG? So its CG is midpoint here. So higher than the ground. If the CG is higher than the ground, it will topple even with little agitation. So that's why you have, let's say, sports car. What is the design of a sports car? It's like flat. It's closer to the ground. So it can take turn at high speeds. Now imagine a bus. Okay, if a bus takes turn at the same speed as a car, it will just stop it. So center of gravity of the bus is higher than the ground. So center of gravity decides the stability. That's why in 9th standard you studied about ballast. We load the ship with ballast, sandbags, etc. So we lower the CG of the boat so that through the waves, sea waves, or through wind blast, the ship does not topple like this. So when the ballast is down, the ship is properly held inside the sea. Okay? So for you to understand, the more close the center of gravity to the ground, more stable that object is going to be. Okay? That's why the solid cone will be more stable. So CG has to be closer to ground, hence H/4. Clear? So this solid cone CG is H/4. So this is about 3D objects. What about plane objects? What about plane objects? Yes. Say a triangle. Huh? This is hollow cone H/3 and solid cone will be H/4. So which is more stable? Solid, because its CG is closer to ground. Okay, all right. Now we have a triangle. So how to find the CG? Again, we'll suspend it at 3 different points. So wherever it, you will see that it will be intersection of the medians. So what is it called? Intersection of median? Centroid, right? It is the centroid. So the centroid is the CG. Okay, that's what it is. And any irregular shaped lamina. Lamina is any plane sheet. Okay. So again, the technique is you hang it at different points, and wherever the plumb line intersects, that's the CG. Okay. Clear? So if you had a parallelogram or rectangle, what will be the CG? Where will it be? Intersection of the diagonals. So triangle, it is intersection of the medians, and for this it is intersection of diagonals. All right. So what have you learned? What is CG? Point concentrated. So, or in this case, if the entire weight is concentrated here, it can be supported here. Right?
Yes.
So meaning, if it can be supported here, therefore all its anti-clockwise moment must be equal to clockwise. So we can also say that this rod is made up of so many constituent particles, right? So if it is symmetric rod, the number of constituent particle will be same on both the sides. So weight of each particle is applying moment of force, right? So if you named it as W1, W2, W3, blah blah blah. So sum of all the. So what is this point CG then in terms of moment of force? CG is a point where sum of moment of force due to its constituent particle is 0. Moment of force is 0 means there is no turning effect. है ना? तो सबको ऐड करोगे, so clockwise anti clockwise को ऐड करोगे तो सम क्या आ जाएगा? 0. So what was the principle of moment? So clockwise moment is equal to anti-clockwise moment. Okay? That means this is equal because if it was here, then this will be minus and this will be plus. So this is the next step, right? So if you would have written it like this, anti-clockwise moment, all positive, minus. So this you get 0, correct? So this is how also CG is defined. Read the definition given in the book. CG is the point at which sum of all its moment of force due to constituent particles weight is 0. Okay? So I think both the definitions you will understand. This definition. Everybody read this definition in the book. See if you have any question. Now we'll take up numericals. Now we qualify to solve numericals from unit. Okay, shall we start? So before solving numericals, we'll take up some numerical like questions from the text. Okay, so which is, there is one question 14 in my book. I don't know what question it is in your book. So there are 3 forces A, B, and C. These are the line of action of forces. A. Is it same in your book also? This diagram. Just check. 15. So in the new book, I think it is 15, right? B is, this is B. So the line of forces are drawn like this. This is C. So what is A, B, C? These are 3 forces, line of action. And O is the point whose perpendicular distances are mentioned from these 3 line of forces. From A it is 0.9 meter. From B it is 0.8 meter. And from C it is 0.6 meter. Each force is 4 Newton. Okay, each force is 4 Newton. So what you have to find is which force has least moment about force. Chalo, who will answer? Let me give the chance. C. Why?
Perpendicular distance.
It is the least. All forces are same. So the answer is C. Since least perpendicular distance. Wrong. Okay. So that is the first part. So this is the reason. This is the answer. Second. Which force has the greatest moment about force? The maximum. Okay. So this will be A. Since maximum perpendicular distance from O. Right. Then name the forces producing clockwise and anti-clockwise moment. Third one is so first let us say clockwise moment. Sorry, clockwise is which direction?
A and B.
And A. Okay. Y. A and B. Anti-clockwise moment. Y. C. So C is producing moment in this one. What is the resultant torque about the point O? Now this is good question. So resultant. So this is equal to sum of torque produced by A plus torque produced by B, torque produced by C. Right? What is torque produced by A? Force is 4 into 0.9 distance. What is the sign of torque produced by A? Plus or minus? Minus, because A is clockwise. Okay. What about B? B is also clockwise, so it will be minus. So 4 into 0.8. C is clockwise, so it will be plus. So this will be 4 into 0.6. Right? So take 4 common. This is minus 0.9 minus 0.8 plus 0.6. So this is minus 0.2. 4 into minus 0. So minus 1.1, right? Isn't it?
Yes.
You were not present in the last lecture. Sign convention. Anti-clockwise movement is taken as positive, and clockwise movement is taken as negative. I had explained. Right? Look here. Z-axis, positive Z-axis and negative Z-axis. So when I make anti-clockwise movement, where is it going? Positive Z-axis. So anti-clockwise is positive. Clockwise is when I tied it. So it's going down. So this is, so we had discussed about it. Here ये दिखता नहीं इन बच्चों को. Got it? Anti-clockwise always will take this cap upwards. So it is positive. And clockwise is always negative because it is taking the cap downwards. Okay? Okay. So now you will get minus 4.4 Newton meter or 4.4 Newton meter anti-clockwise. Who said clockwise again? Anti-clockwise, no negative. Ah. Okay. Clockwise. I just explained. Huh? Good. So you argue. So this was a good question, not in numerical, but good for understanding the concept. अभी भी किसी को clockwise, anti-clockwise में problem है? पक्का? चलो next, she is going to solve numerical way. Okay. Just kidding हाँ, किसी को कोई डरने की जरूरत नहीं है. इसका मतलब ये नहीं कि तुम ठीक है चलो. कोई लिख रहा है या मिटा दो इसको? ऑनलाइन स्टूडेंट्स एक ही है क्या?
Yes, sir.
Yes, question. Can I erase it?
Yes, sir.
आवाज नहीं आ रही क्वेश्चन.
Yes, sir. You can raise.
Okay. अच्छा एक और क्वेश्चन है ये वाला. See what question number is that? 16. चलो who will answer? Question 16. पढ़ो पहले इसको. So there is a spherical object, right? You have to push it so that it climbs the pavement, XY. So usme, what is the, you have to show the point in this diagram where the force has to be applied so that in minimum moment of force it climbs XY. हाँ बोलो. How? Come here, come here. हाँ. Let him. बताओ कहाँ पे लगेगा? हाँ बनाओ, point बनाओ. Very good. बैठ जाओ. Is it correct? How many are saying it is correct? जोर से बोलो. नहीं मैं भी ये करेक्ट नहीं है. आ जाओ. सबको आना है यहाँ पे. रॉन्ग होता है तो होने दो. इट्स ओके. ये करेक्ट नहीं है. कोई बता सकता है ये करेक्ट नहीं है? क्वेश्चन में क्या लिखा है? मिनिमम मोमेंट ऑफ फोर्स चाहिए. चलो भाई, किसी को लग रहा है कि सही है या गलत है? सही है. सही है आप बताओ. ये पॉइंट कहाँ पे है तुम्हारा? हाँ? ये कहाँ पे? इस पॉइंट के अपोजिट डायरेक्शन, डायमेट्रिकली अपोजिट. ठीक है? आ जाओ. गलत है. गलत है, गलत। ओके, क्वेश्चन सब गलत है, किधर किधर क्वेश्चन वेयर शुड बी द फोर्स। हाँ मैं बोल रहा हूँ, एक बार क्वेश्चन को ट्राई करना।
सर नहीं होगा सर।
क्वेश्चन योर चांस।
सर नहीं आता सर ये वाला।
पास पास।
यस सर।
ओके क्वेश्चन इज एक मिनट बोलो। बोर्ड पे आना है, जो भी ट्राई करना है बोर्ड पे बताओ। ओके वी हैव लेस टाइम, चलो ये लास्ट he is closest, at least he got the point right, he only got the direction of force wrong. Right, your point is correct. If he would have driven like this,
rotation I side से तो वही बोल रहा है।
मैं तो वही बोल रहा हूँ, ठीक है। ये क्यों गलत है, देखो मोमेंट ऑफ फोर्स क्या होता है, परपेंडिकुलर डिस्टेंस। इस पे चलाना था, देखो एक मिनट सब देखो, मोमेंट ऑफ फोर्स अबाउट एक्स निकालना था, तो मिनिमम फोर्स कब लगेगा, जब मैक्सिमम डिस्टेंस मिलेगा। So it has to be first of all this point, right? And this arm has to be perpendicular. तो force का direction क्या होना चाहिए, ऊपर।
So if it again सब once से try करें तो
फुटबॉल में बेटा ऐसे कहाँ, तू प्लेन फील्ड पे खेलता है तो वो इस पे एप्लीकेबल नहीं। फुटबॉल में क्या है, नहीं यू लिफ्टिंग, this is like rotating, it's not lift, it's rotation, it is touching, so this becomes the pivot, okay। तो फोर्स कहाँ पे लगना चाहिए, इसके मैक्सिमम डिस्टेंस पे। अब देखो ये सारे डिस्टेंसेस मैक्सिमम है क्या, वैसे ही रिजेक्ट हो जाता है। फॉर मिनिमम एफर्ट द परपेंडिकुलर डिस्टेंस शुड बी मैक्सिमम, तो इसका डायमेट्रिकली अपोजिट पॉइंट होगा, बट वो परपेंडिकुलर होना चाहिए। तो या तो तुम इसको ऐसे बनाओ या फिर ऐसे बनाओ, एक ही बात है। गॉट इट? सो दिस इज, सो मजा आ गया सबको, है ना। We have 5 more minutes. Now we'll go to numericals. So everybody's concept is clear now. ठीक है? चलो, numerical 1. Numerical 1. Yeah, numerical 1. So the way we'll follow is, you raise your hand. Who would like to try? ठीक है? And then I will select. कौन कर, बोर्ड पे करना है सबको, ठीक है? You can come minimum 2, I mean minimum 1 and maximum 2, ठीक है? ठीक है ना, 2 जन आ सकते हो साथ में, अगर कोई डर रहा है तो। डरने वाला तो मुझे वैसे कोई दिख रहा नहीं है। He will come always alone. कौन आ रहा है फर्स्ट न्यूमेरिकल? चलो मैं बुलाऊं, तुम आ जाओ। बुक लेके आओ, बुक लेके आओ। सो क्वेश्चन 1 क्या है, मोमेंट ऑफ फोर्स ऑफ 10 न्यूटन अबाउट अ फिक्स पॉइंट O। क्या दिया हुआ है, फोर्स इज गिवन। सबसे पहले क्या करना है, गिवन सर दिस इक्वल टू कितना है, 10 न्यूटन। Everybody is trying to notebook, okay, and then we'll match the answer. तो easy है, इसलिए तो उसको बुलाया ना। मुझे बुलाता हूँ। Note of which point? So is it moment of force or force? How do you figure out by the unit?
Yes.
Yes, correct. Yes, correct. I was checking you. So this is force. Why? Because you have correct. Then एक second. What is the torque? Torque given is 5 Newton. ये दिया हुआ है. Calculate the distance of point O from the line of distance. कैसे निकालेंगे? चलो निकालो. What is the relation between torque, force, and perpendicular distance?
Sir, torque is equal to force equal to
देखो, torque is equal to force into perpendicular distance. Therefore, perpendicular distance is equal to
torque upon force.
torque upon force. Point by क्या? Unit? Distance के लिए distance निकालो. चलो clap for him. We will now go to third question. Okay? Second वाला भी easy है, ठीक है? Yes, Lord. Third question. चलो, wheel of diameter 2 meter is ये एक wheel है, ठीक है? इसका diameter कितना है? 2 मीटर. मतलब रेडियस कितना हुआ? रेडियस हो गया 1 मीटर, ठीक है? अब इस पे क्या किया है? ये पॉइंट बी है. एट पॉइंट बी फोर्स लगाया है कितना? ठीक है. और ये क्या पॉइंट है? ये पॉइंट है ए. ठीक. क्वेश्चन क्या पूछा है? सेंटर. तो दो जगह निकालना है. वो कितना है? दूसरा क्या है? सेंटर पॉइंट ए. ये दो चीज निकालोगे, ठीक है?
सर ये टॉर्क का सिंबल सर
टॉ. इट्स कॉल्ड टॉ. टॉ प्रोनाउंस एज टॉ. ठीक है? हाँ बताओ. तो ओ पे, ठीक है, 2 into 1 मिलेगा, है ना? ओ पे कितना होगा? 2 into 1 equal to 2 न्यूटन. अच्छा, 2 न्यूटन मीटर ये कहाँ पे लग रहा है? तो ये हो जाएगा -2 या फिर क्लॉकवाइज. ठीक है? ये वाला कैसे होगा? ठीक है, सिंपल है. और क्या सेंस बनेगा? ये भी क्लॉकवाइज ही है. ठीक है? तो ये पूरे चैप्टर में न्यूमेरिकल्स बहुत ही सिंपल है अगर तुम्हारा लॉजिक क्लियर है और साइन कन्वेंशन क्लियर है. ठीक है? बस ये दो ही चीज है. हाँ, तो या तो ऐसे लिखो या फिर -2
लिख सकते हैं ना -2
लिख सकते हैं. किसी किसी क्वेश्चन में स्पेसिफाई किया होता है कि साइन में लिखना है या डिस्क्राइब, वो देखना क्वेश्चन में क्या है. ठीक है? अगर मेंशन नहीं किया तो तुम कुछ भी लिख सकते. ठीक है? We have time for one more question. 35 है ना? 5 minutes. We can do 2 more questions. Question 4. My book, it is numerical 4. Just check what is it. This question.
Yes sir.
Question 4, right? This is 2 meter. This is 4 meter. ठीक है? So what is the question? First question is T1. क्या निकालना है फर्स्ट क्वेश्चन में? मोमेंट ऑफ फोर्स F1 अबाउट O. तो ये कितना हो जाएगा? T1 अबाउट O निकालना है. T1O. ठीक है? This is second point is the pivot. First is the force. Force pivot. Okay? That's the convention. F1 into A4. Okay? So what is this? 5 into 10 Newton meter. What is the sense?
I think
This is plus. ठीक है, सबको समझ आ गया? और क्लॉक एंटी क्लॉकवाइज क्या होता है? प्लस 10. ठीक है ना? चलो सेकंड वाला बताओ. अपने तुम लोग शॉर्टकट अपना प्रेजेंटेशन भी अच्छा रखना है. ठीक है ना? अगर सारे मार्क्स चाहिए तो कैसे करोगे? दिस विल बी F2 into OB. क्या होगा ये?
3 into 4. 12 Newton meter. Clockwise.
ये कैसे हो रहा है जी?
Clockwise. Minus 12 Newton meter.
Yes. कोई एक भी बच्चा है जिसको नहीं समझ में आ रहा है, प्लीज आस्क. डोंट हेजिटेट और डोंट बी शाय. इट्स ओनली योर लॉस. हाँ, क्या बोल रहे हैं? नहीं, पीपल कैन स्पीक फॉर देमसेल्फ. Nobody is a appointed secretary of anybody. नहीं, वो हम देख लेंगे. Are you appointed secretary? Don't text secretary. चलो, कोई है जिसको नहीं समझ आया? चलो, last year. Total moment of two forces. So total moment is ठीक है ना? टोटल में नेट टॉर्क स्पीड एंड कितना 10. अब इसमें प्लस साइन क्या आएगा? तो ये जो एडिशन होता है उसमें साइन वाला ज्यादा हेल्पफुल है. ठीक है? तो कितना आ गया? -2 मीटर क्लॉकवाइज. ठीक है? So I think that this question is quite clear. So in the next class we'll do some more numericals. Next lecture will be our fourth lecture, right? First lecture was of 2 hours or 1 hour. There was never a 2-hour lecture for each. This is our second lecture. Hey.
Based on 3 months periodic table.
Last week.
It was